quiz, it's like just what you said. It's finding derivatives. So we have some generic ones where I give you an equation and ask for the derivative. We have some where I ask for the equation of the tangent line or of velocity. It's all kind of the same thing. So let's do a few review problems and kind of make sure we know what to do in each scenario. So if I said I want the equation of the tangent line to at the point 5, 2. Okay, so I'm asking you for equation of a line. Equation of a line requires a point and a slope. I gave you the point. How am I going to get the slope?
The limit of h approaches 0.
We're just finding the derivative. So the limit as h approaches 0. F of x plus h. You could leave this as x plus h minus 1. Or what could you replace your x with if you wanted?
A if you wanted to, but that's wrong.
Yep, you can have it as an a. Or what else could we use in this problem? We could go ahead and plug in the 5. So any of those options will work because we do know the point. Do you want me to go ahead and put it in the 5?
Yeah.
Okay. So because, and only because we have a particular x value, I could go ahead and sub that in here. So f of x plus h, so f of 5 plus h, minus f of x. So if I put it in a 5, we just get out 2 all over h. All right, so now it's back to limits and all of our strategies for evaluating limits. When you have a radical, what was our strategy? Conjugate. I'm going to combine like terms first. Under my square root, so 5 minus 1 will be a 4 plus h. So then I'm going to multiply by the conjugate. So we get the limit as h approaches 0. That would be a 4 plus h minus 4 over h times this. Now what? Right. So if we divide those h's, that just gives me 1, and now we could plug in. So we get 1 over square root of 4 is 2, plus 2 is 4. So now I have the 1/4, which is my slope. We had the point, so plug into y equals mx plus b. We get a b value of 3/4, so the equation of the tangent line at that point is y equals 1/4 x plus 3/4. Alright, so if I ask for equation of a tangent line, we have to do the derivative to get the slope and then write in the equation. Can we do that?
Yes.
Okay. What if I said, is traveling along the path y equals 10t minus 3t squared. Find the velocity at t equals 30. Alright, so I've given you a position. How do you get a velocity? Yeah, so we need the derivative of this, or the limit, as h approaches 0. F of x plus h. You can do x plus h, or what could we put in? 3 plus h. I'll go ahead and do that. So 10 times 3 plus h minus 3 times 3 plus h squared minus f of x, so if you just put a 3 in, all over h. So what do we do? Let's start multiplying it all out. Can I square this and distribute a 3 at the same time?
Yeah.
Okay, so that would be 9 times -3, so negative 27. 6h times 3. Minus this would be 30 minus 27 over h. Alright, so 30 minus 27 is 3, but then I have a minus 3 here, so that all cancels.
Wait, isn't it the minus? Never mind.
Are we alright?
Yeah.
Okay.
I just didn't do something, but it's the same thing.
So if you take an h out of everything, and then if you plug in 0, you get negative 8. So my velocity is negative 8. I didn't give you units, probably feet per second or something like that. Why is it a negative? What would that negative tell me?
It's decreasing.
Right, it's decreasing, it's going down. That's
Do you want to go somewhere because it's right?
all right. Is that one okay? So that was really like the 2.7 where we had actual numbers to plug in. But I could just ask you to find a derivative of a function. So let's say I gave you Alright, if I asked for the derivative of this, what is the derivative? The limit thing that we've done on the last two problems. The only difference is, do I have an actual x value to plug in this time? No. So we have the limit as h approaches 0, f of x plus h minus f of x all over h. What is our strategy here? Common denominator. So this one needs a 5 plus x. And this one needs the 5 plus x plus h. instead of divided by h, I'm going to write times 1 over h. Now what?
Just trying to combine.
So 10 and negative 10 cancel, positive and negative 2x cancel. So now we can reduce the h, and now we should be able to plug in. So we get negative 2 over 5 plus x squared. So if I asked you to do the derivative from the equation without a number to plug in, can you handle that? The other things we've done related to a graph. If you're looking at a graph, what does a derivative represent?
Wait, what was the question?
What is a derivative when you're looking at a graph? What is
It's the little,
Slope tangent.
like, yeah.
slope of the tangent line? Good. And we have done some, well, that first question on the homework, you had to estimate all those derivatives just by drawing the tangent line and guessing, somewhat guessing, using some reasoning to get the slope. I could also, we've had some on the homework where it gave you a graph and asked you to draw the derivative of it. So if I gave you something like this. Okay, if I asked for this derivative, what would you do? What do you look for first?
0.
So we would have a horizontal tangent line here, here, and here. So those three places, the derivative would be 0. This section of the graph was all increasing. So what does that tell you about your derivative? This section was decreasing, increasing, and then decreasing. So using a graph to draw the derivative. This is really a lot less information than you're used to having on a quiz because the two sections were really doing the same thing, just derivatives over and over and over again. So let's take some time now, work on that homework assignment that's due tomorrow.